Hello. All right, we are on to lesson 6, problem set for module 6. And today we're going to be taking a look at line plots. So on number 1, it says Coach Harris measures the heights of children on his third grade basketball team in inches. The heights are shown on the line plot below. So we've had some experiences with line plots in the past. It's just another way of organizing data. It utilizes a number line and then kind of like a picture graph uses symbols above that number line to indicate how many of each interval you have. And our key over here is telling us that an X is equal to 1 child. We have height in inches listed on the bottom, and then that's pretty much included in the title as well, just also sharing that it's a third grade basketball team. So today we're going to have to kind of pull our attention into specific vocabulary, and I'll mention it when it comes up to help us understand how to answer these questions correctly. So question A says, how many children are on the team? How do you know? Well, we know that 1x equals 1 child. So to determine how many kids are on the team, what do you think we need to do? Yeah, we have to count the x's. So we have 2 plus 3 more makes 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15, a different pencil, hold on one second. 15 kids. And I know because I counted each X. How many children are less than 53 inches tall? All right, so less is one of those key vocabulary words. We've used it in calculations, right? How much more or how much less or how many fewer, right? Those are words that indicate a difference. So it says, how many children are less than 53 inches tall? So if this is 53 inches, they have to be less than that amount, which means that we have to look at measurements less or smaller than 53. So we have 1 that measures 52 and a half. We have 3 that are 52 inches. That makes 4 students, 5, 6. So there are 6 students that are less than 53 inches tall. Coach Harris says the most common height for the children on his team are 53 and a half inches. Is he right? Explain your answer. Well, 53 and a half definitely is a common height. And we know this because it has 3 students, right? So out of all the measurements, that seems to be one that a lot of kids measure. But if we look at our full number line, what do you notice? Well, hopefully you notice that 52 also has 3 students that measured that height. So this is a common height, but this is an equally common height. And we know that because they both have the most number of kids that fall at that height. So most common means the most often marked on the graph. So is he right? No. 52 inches and 53 and a half inches both had the most kids. They were equal with 3 kids for each. Probably not the most clear language, but I would think it'll get the point across clear enough. Coach Harris says that the player who does the tip-off in the beginning of the game has to be at least 54 inches tall. Okay, so on this at least, I want you to think about when we do sprints and we celebrate progress. It's like if you have improved by at least 1, stand up. If you have improved by at least 2, stay standing, right? So it means that you have to have that amount as the minimum, or you can have more than that amount, right? So when we go to our plot, our line plot, they have to be at least 54 inches tall. Okay, so at a minimum, this kid right here qualifies for the tip off. Now, there are other kids on here who also qualify for the tip off. Would we look this direction where they get shorter, or would we look this direction where they get taller? If they have to be at least 54 inches. This is also like when you go to an amusement park and you have to be measured for a ride. You must be at least this tall. You can be taller, you just can't be shorter, right? So these guys over here also qualify as tip-off candidates. So how many children could do the tip-off? 1, because he just meets that requirement, or she. 2, 3, 4. 4 students could do the tip off. Okay. Let's see. The next page of lesson 6 is here. Mrs. Vernier's class is studying worms. Fascinating. The length of the worms in inches are shown in the line plot below. Wow, that's lots of worms. And it looks like we have a few plotted points that maybe got misprinted. This is looking a little wonky to me here, and I think that guy's supposed to be over here too. So we have lengths in inches down here. Each X is equal to 1 worm. How many worms did the class measure? So again, if each X equals 1 worm, all we have to do is count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay. 30. I counted, whoops. Each X. Kara says that there are more worms 3 3/4 inches long. Okay, so that's here. Than worms that are 3 2/4 and 4 1/4 inches long combined. Is she right? So let's go ahead and see how many there are in this combo deal here. So for this one, we have 4 plus 4 1/4. There are 4 over here. Okay, so combined, they have 8. And on the 3 3/4, there are 1, 2, 3, 4, 5, 6. So there are 6 over here. She says there are more of these ones than there are of these combined. So no, she is not right. 3 3/4 inches long only has 6. And my math work over here shows that the other has 8. C says, Madeline finds a worm hiding under a leaf. She measures it and it is 4 3/4 inches long. Plot the length of the worm on the line plot. So 4 3/4 inches long would be right here. And here is her worm. Good. Not too bad. You just have to really kind of pay attention to the vocabulary, the combining, the at least, stuff like that. So just take your time and reason your way through it. But line plots are pretty user-friendly, and all of our X's are only equal to one thing. So it should be a nice, comfortable launching point. All right. Look forward to seeing your homework.